A radical equation is one where the x variable that we're trying to solve for is located under a radical. Now, in order to solve for that variable x, the first thing that we're going to want to do is isolate the radical, and then we square both sides or raise both sides of the equation to the same power as the index in that radical. So if it's a square root, we'll square both sides. If it's a cubed root, we'll cube both sides. Let's start by isolating the radical, get that radical by itself on one side. So we add 4 to both sides. So on the left, we just have that radical, negative x plus 3, and on the right, we now have 4. Once the radical has been completely isolated, this is where we want to square both sides here in order to remove the radical and make that radicand, which is what's under the radical, now accessible. So the square root of a quantity squared, those operators cancel each other out, and we now have that radicand, negative x plus 3, liberated and accessible. And on the right-hand side, we have 4 squared, which is 16. Now we can use our standard linear process in order to solve for x. We'll subtract 3 from both sides to get negative x is equal to 13. And once we divide both sides by negative 1, we've now solved our equation. X is equal to negative 13. In our last step here, it does say that we want to make sure we're checking the answers for any radical equation, because radical equations in particular can sometimes yield extraneous solutions, which means the solution we generate might not work in the original equation, even though we didn't make any mistakes when we calculated it. So let's check our answer by looking at that beginning equation. We'll open up the whole for x plus 3, and then we have minus 4 is equal to 0. And we'll plug our solution, negative 13, in for that x. So we get positive 13 plus 3 minus 4 is equal to 0. Positive 13 plus 3 is, of course, 16, which is 4 minus 4 is equal to 0, so our solution does work. Now let's look at another example. Again, we're going to want to start by adding 9 to both sides to isolate that radical. The 9's cancel out, and we have 3 times the cubed root of 2x minus 4 under the radical is equal to 9. We can go ahead and divide off that 3 as well, canceling it here on the left. We end up with the cubed root of 2x minus 4 is equal to 3. And now we're going to raise both sides to the cube power instead of squaring both sides. Because the index is 3, that means we need to cube both sides in order to eliminate this radical. So the cubed root of a quantity cubed is going to cancel each other out, and we'll have 2x minus 4 that remains on the left and 27 on the right. So we now add 4 to both sides to solve for x. We get 2x is equal to 31. And when we divide both sides by 2, we get our solution of x is equal to 31 over 2. Let's check this answer on our calculator by taking 31, dividing that by 2, and then that quantity, let's store it into our x variable. And then we hit enter to make sure that it goes in. Then we'll go back to the beginning problem, which was 3 times the cubed root. And in order to get the cubed root, we're going to select math. And then right down here in that math menu is the cubed root. So we can hit either arrow down to get number 4, or we could also hit number 4 and then hit enter. So that gives us our cube root. Now we'll say 2x minus 4. Remember, our answer is already stored into that x value. And then we'll come out of the radical and go minus 9, and then hope that we end up with 0, and we do. So our solution does work in this second example. And for our last example, we're going to subtract 6 from both sides in order to isolate that radical. So we have the square root of x is equal to x minus 6. And this time when we square both sides, we're going to have to square a binomial on the right. Squaring this radical squared on the left, we end up with just x. And squaring the binomial on the right, let's recall that squaring a binomial is taking that binomial and multiplying it by itself. If we FOIL this out, multiplying the first terms together, we get x squared. The outer terms are going to give us negative 6x. Multiplying the inner terms together, we get negative 6x again. And then multiplying those last 2 terms together, we're going to get plus 36. So this yields x squared minus 12x plus 36. And that's what we get when we square that binomial. So this right-hand side then is that square the first quantity, twice the product, and square the second quantity. which is what we got over there. Now we have a whole new kind of equation, and this time it's quadratic. In order to solve a quadratic, we want to set it equal to 0. So we'll subtract x from both sides and get x squared minus 13x plus 36 is equal to 0. And this factors into x minus 9 times x minus 4. We're still equal to 0. And when we set each of these factors equal to 0, we get x is equal to 9 and x is equal to 4. Now, as with all radical equations, we definitely need to check our answers, which means that we start with one of the solutions and we're going to plug it back into the original to see if it works. The original equation was the square root of x plus 6 is equal to x, and we're going to plug our solution, which is 9, into the x values. Square root of 9 is 3 plus 6 is equal to 9, so our first solution does work. So we'll put a star on that one to indicate that we've checked it. Now we're going to check the second solution back into the original. So we plug 4 in for x in both of those x spots. Square root of 4 is 2 plus 6 is not equal to 4. So this second solution does not work and would therefore be considered extraneous. And radical equations in particular are one kind of equation that will sometimes generate an extraneous solution, which is why we have to check all of our answers every time.